So what does that mean? So DevSecOps in practice. So, as I said before, DevSecOps is a combination of people, process, and technology. It's not just a set of tools, for example. So when we talk about DevSecOps, what we're talking is providing training. So ensure everyone understands the security best practices that you've developed and how attackers operate. What to look out for, what to design around. Define a sort of baseline requirement. So establish a minimum security baseline that considers security and compliance controls, and ensure this is baked into your DevOps processes and pipeline. I'm going to talk a little bit more, give you a bit more a slightly more real-world example later about how you could do this within the Microsoft Azure tool sets. Drive the correct behavior to support objectives. So again, following on from those DevOps principles of monitoring and feedback loops, what are you trying to achieve? How do you measure that, and how do you know whether something's been successful? How do you how do you drive down? How do you make sure that you're getting better? There's a couple of just examples here. So looking at mean time to detection of a security event, or mean time to recovery from a security event, etc. But there's a whole load more. But they should be supporting the objective that you're trying to achieve as part of your as part of the security within your company. So it's quite an interesting one and topical, probably 18 months or so ago. Understand where third-party components are used. Within a development environment, there's a lot of code reuse, not just in your code, but in code that you may be using from other people as well. So understanding those components, understanding where they sit within your applications is pretty key. So you can then understand the possible impact if that code is vulnerable. So as an example, the Log4j vulnerability that surfaced, I think it was about 18 months ago, may have been a bit longer. That people didn't even realize that they were using Log4j code in all their applications, or a majority of their applications, until it's become an exploit has been realized. So maintaining an understanding of your software composition is pretty key. Perform threat modeling. So slightly tricky one with a DevOps approach, because it could be seen to slow it down. But spinning up a threat modeling environment, looking at identifying security vulnerabilities and mitigating before code release is pretty key. And you can do it in a way that doesn't stop that DevOps cadence. You can spin up environments very quickly with DevOps, infrastructure as code, that type of thing. You can tear those environments down very quickly. You can use automated test tools to model for threats and look for exploits. And it follows on quite nicely into the use tools and automation. So you can integrate select tools within your DevOps processes. So things like static application security testing, SAST, into your integrated development environments, dynamic analysis security testing into your CI/CD pipelines, that type of thing. Static applications testing will look at individual components, and then the dynamic will look at start to look at the security of your code as you're bringing in and integrating all your components together. Another key one is keeping your credentials safe. A number of times I've seen within applications, people have hard-coded logins and credentials, login credentials, usernames, passwords, whatever, within source files. So someone has access to those source files, they then have access to everything because they've got those user credentials. And then using continuous learning and monitoring, so monitoring your applications, infrastructure, and network with advanced analytics. Again, part of that, those DevOps principles, but branching out into that security space, so you can uncover security and performance issues. And it's it supports that defense in depth. So it's not just around when you're developing your app, it's actually when it's operational as well. And then it provides that feedback loop. You know, you're looking at your you're looking at your app as it's being used by others, and you're responding and reporting back on that on security breaches, which then feeds back into that development lifecycle. So pretty theoretical at this point.